Assalamualaikum and a very good day to my panels, which is Puan Rohaina binti Jaafar and Datin Dr. Fazila binti Qasim. Today, I would like to present about my poster, which is Development of Dual Axis Solar Tracker with IoT Monitoring System. First of all, I would like to reintroduce myself. My name is MUHAMAD FIRDAUS bin MUDZIR, and I'm from Faculty Electrical and Electronic Engineering Technology from class BEY. Next, my supervisor, which is Encik Mazri bin Ibrahim. So this is my poster. For introduction, nowadays electricity demand is increasing and it is leading to a shortage of energy sources. Renewable energy comes from natural sources or processes that are replenishing, such as solar energy. Solar energy is an energy that captures energy from the sun and converts it into electricity. For the project description, the purpose of the project is to improve and increase the efficiency of solar panel by installing and development of dual-axis solar tracker with IoT monitoring system. The project installed the sensor to keep track of sun all day, using microcontroller to process the data signals from input and motor to rotate the solar panels in specific location. Testing and taking measured values on this panel is done using multimeter on a daily basis due to frequently changing weather conditions. For the problem statement, firstly, most of the solar panels are in a static position which does not face forward to the sun. Secondly, fixed solar panels are lack of energy collection by sun throughout the day. And lastly, the problem is it only can monitor via LCD only and not via an online system. For the objectives, firstly is to design a dual-axis solar tracker that moves independently in both x-axis and y-axis. Second, to develop a monitoring system controlled by a Wi-Fi module. And lastly, to analyze the output parameters of solar panels. For the research methodology, this topic consists of two parts, which is hardware and software. For the hardware, firstly is Arduino Uno, solar panel 3W 9V, the two servo motor, which is SG90, voltage sensor, current sensor, and the Wi-Fi module, which is ESP8266, LDR, and also LCD. For the software part, which is Arduino IDE software, Proteus 8 Professional, SketchUp, and Blink application. So this is the block diagram for the project. I'm using 4 LDR sensor and the output, which is Blink application, servo motor for vertical and horizontal, and LCD. And this is the flowchart of the system. The flowchart and block diagram guidance includes the selection of LDR as an input and transfer the signal to the microcontroller to move and rotate the motor with specific position. For the result discussion, the comparison between the dual-axis solar tracker and single-axis tracker. So I've done this experiment on 2nd January 2022. I'm compared the dual-axis solar tracker with the single-axis solar tracker. So this is the graph for voltage versus time, current versus time, and also power versus time. As we can see, the dual-axis solar tracker produces more voltage, current, and power than the single axis tracker. The curve produced by single axis and dual axis solar tracker system slightly different. The dual axis solar tracker is outperformed than the single axis solar tracker when the solar panels absorb solar energy from the sun between 9 am to 6 pm. In general, a dual axis solar tracker system receives more sun rays and produces more voltage, current and power than a single axis solar tracker. So this is power versus time, and this is schematic diagram using Proteus 8 Professional, and this is for IoT monitoring system display. The temperature and humidity around the solar panels are not available, so Internet of Things, which is IoT, was used to detect the temperature and humidity of surrounding by using Wi-Fi ESP8266, and it was sent to the Blink application. This is the project hardware. It is important to use hard and solid materials as the material for the solar panel to withstand severe weather conditions such as heavy windy days. Thus, create a solar tracker that can be tracked by long range using Internet of Things. And finally, it can generate and produce more power, energy than fixed solar panel. For the conclusion, as a conclusion, the dual axis solar tracker has been successfully developed. The monitoring system, which is Wi-Fi module, able to transfer data from solar panel to the Blink application. It has proven that this mechanism is potentially better than fixed solar panels. This solar tracker has two movements that can be classified as horizontal and vertical axis. Finally, the solar tracker has the potential to revolutionize our society and more environmentally friendly to utilize due to its lack of pollution. For the recommendation, this project is successful in meeting all stated objectives and satisfies all target requirements. Although there are some limitations that can be overcome, improved, or upgraded in the future, including the following. The first one, improvements to the IoT platforms to receive multiple outputs at one time to receive the purpose of the monitoring system. Second, to enhance the development of a system capable of being utilized in extreme weather conditions. And lastly, add battery for system storage to use at night. This is the references. And this is for my bachelor degree project to Ganjat. Thank you and Assalamualaikum. Have a good day. Assalamualaikum and hi. My name is MUHAMAD FIRDAUS. Today I would like to do the demonstration project for my project, which is development of dual axis solar tracker. So the component that I have used for this project is LDR. So there are 4 LDR, which is top right, top left, bottom right and bottom left. And the solar panel, which is polycrystalline solar panel, 3 watt and 9 volt. Also the servo motor, which is 2 servo motor for horizontal and vertical axis. Next, LCD and Arduino as the microcontroller. DHT11, which is humidity sensor. And lastly, Wi-Fi module, which is ESP8266, and to send the data to the Blink application. For video demonstration, 5 volt voltage is supplied to the circuit. And the LCD will turn on and display servo motor on, and the LDR is function. So to test the LDR, flash act as the sun rays to detect the movement of the sunlight. So there are 4 LDR sensor, which is top right, top left, and bottom left, and also bottom right. So the motor will move slowly, depends on the sunlight. So the horizontal axis also will rotate slowly, depends on the sun's movement. For measure the voltage and current, multimeter is used. For positive probe is connected to the positive terminal of the solar panel, and negative probe is connected to the negative terminal of solar panel, and the voltage will display 9 volt voltage. While to measure the current, the probe is connected series with load to measure the current. For the IoT monitoring system, I am using Wi-Fi module, which is ESP8266, and the DHT11 for temperature and humidity sensor. So connected to the power bank, and it will send the data to the Blink application, and it shows the temperature is 33.7 degrees Celsius and the humidity is 60.